Hi, a good day. Today we're going to learn integration, and the learning outcomes related to integration are anti-differentiation or anti-derivative, indefinite integrals, rules of integration, definite integrals, area above and below the x-axis of a curve, and area between two graphs or two curves. And lastly, basics of differential equations. Antiderivative. Antiderivative concept simply means, for example, if you have the function x cubed and when you differentiate x cubed, you will get 3x squared. And when this 3x squared function, which is actually dy dx, is being integrated, which simply means anti-differentiate, will actually produce x cubed. So therefore, integration is actually the reverse of derivation, which means integration is actually anti-derivative. The concept of anti-derivative can be further explained as below. When you have three different functions such as fx, gx, and hx, which are x squared plus 2, and x squared minus 7 respectively, when all these three functions fx, gx, and hx is differentiated with respect to x, the resultant is actually 2x. When you differentiate fx, you'll get 2x, gx also 2x, and hx is also another 2x as the derivative. So therefore, I would just like to explain the concept of C, which means a constant of integration. Any function being integrated will actually result in the integrand plus the C, which is the constant of integration. Since the functions of gx, fx, and hx differ only by a constant, where the constant of g is 0, constant of f is 2, and constant of h is -7, despite the three constants being different, the slope of the tangent line remains the same for these three functions. The slope of the tangent line is represented by the dy dx, where the dy dx of gx, fx, and hx is 2x, despite having a different integration constant. Indefinite integral. Indefinite integral simply means when you integrate a function with respect to x, your resultant will be the integrated function added with the constant of integration, which is known as c. Just to take note, c only exists for indefinite integrals. C does not exist for definite integral, which we will look at it in the later slides. For example, this is known as the integral sign. Fx is known as the function being integrated is known as the integrand. And dx simply means the variable that you are integrating with respect to. So for example, if your x here is dt, meaning your function most of the time is in terms of t, and you're actually integrating with respect to t. For this function here, you are integrating with respect to x. This is called the indefinite integral and is the most general type of antiderivative of a rules of integration. These four rules stated here are used as a guide to actually integrate the functions in the coming few slides. So for example, if you have a to the power of x, ax to the power of n, you actually integrate it such as a is a constant, leave the constant alone, your focus is to integrate x to the power of n. So actually increase the power of n by 1, and you actually divide with the new power, the new index at the bottom. Divide the function with n plus 1, and of course you add c because it's an indefinite integral. When you integrate cosine, you will actually get sine ax plus b, and you always divide it with the coefficient of x. Same goes with sine, but the only difference is you'll get the resultant as a negative cos ax plus b, and you divide it with coefficient of e. Please remember the signs correctly. And if you have a function in terms of ax plus b, this only applies to a linear function to the power of n. So you copy it back and you add the power here, n plus 1, and you bring the n plus 1 to the bottom and multiply it with the coefficient of x. And don't forget to add your constant for integral. Okay, now let's apply the rules of integration to integrate the functions below. Integrating 5x squared minus 8x plus 5 will result in, using the x to the power of n integration basics, 5x cubed, 2 plus 1 is cubed, over n plus 1 brought to the bottom, which is 3, minus 8x squared over 2, which will result in minus 4x squared. And a number 5, integrate a constant, will actually give you 5x. And because this is an indefinite integral, therefore you need to add the c. Applying similar rules for the next two functions will actually result as integrating this function will result in negative 6x power 4 over 4, which can be further simplified to negative 3 over 2 times x power 4. 9x cubed over cube, so will result in 3x cubed, plus 4x squared over 2, which can be reduced to 2x squared. Integrating a constant will again give you minus 3x. And don't forget to add a c because this is an indefinite integral. The next function, using similar rules, x to the power of 3 over 2, add 1 will become 5 over 2, divided by 5 over 2. When you divide with 5 over 2, you will get flipped. Multiply by 2 over 5. And integrating 2x gives you 2x squared over 2, which can be simplified to x squared. And integrating a constant gives you 3x. And don't forget to add the c because this is an indefinite integral. Integrating function such as 8 over x. Okay, this is a rule of thumb. When you integrate 1 over x, you will get ln x. So therefore, integrating 8 over x will result in 8 ln x. And integrating 5x over x squared, which can be written as minus 5x negative 2. So using the x to the power of n integration rule, this becomes negative 2 plus 1 will result in negative 1 divided by negative 1. So therefore, this can be further simplified to negative, negative, it becomes positive. So it becomes 5 over x. And integrating 6 over x cubed is actually integrating 6 over negative 6 to multiply by x negative 3. So therefore, this can be integrated such as 6x negative 2 over negative 2. So it will result in minus 3 over x squared. And of course, again, don't forget to add your c because c is the constant for the integration for an indefinite integral. Same goes for the next question, next number 5. When you have surds, please write it in linear form first, as in change the surd to a number index. So x power of half, 1 over 3 multiply x to the power of negative half. This is basics of index law applied here. and then you can integrate. So x 1 over 2 plus 1 will result in 3 over 2 divided by 3 over 2. So when you divide it, it will flip to 2 over 3 multiplied by x power 3 over 2. Same goes for here. X power negative half plus 1 will give you x power half. And the 1 over 3 is a constant. We leave the constant in front here. Add the index with a 1, which will result in half, and bring the half to the bottom. Divide by n plus 1. So when 1 over 3 and 1 over 2 is combined, the resultant will be 2 over 3. X power half. And of course, don't forget to add the c again. When you have fractions as your index, please be careful when you add 1 to the index power. To avoid careless mistakes, please use calculator to do your calculation for the addition of fractions. So 3 over 4 plus 1, 7 over 4. And when you divide with 7 over 4, it becomes multiplied by 4 over 7. So 4 times 12 is 48 divided by 7. And for this, same rule applies. 5 over 3 plus 1 becomes 8 over 3. And you divide by 8 over 3, it becomes multiplied by 3 over 8. So 9 times 3 is 27 over 8. And of course, you add the constant c. When you have functions like number 7, you should actually simplify it to individual terms first. So as in x squared over x squared gives you 1. And plus 4 over x squared is 4x negative 2. So when you integrate this, integrating a constant 1 gives you x. Integrating 4x negative 2, it becomes 4x negative 1 over negative 1. So therefore, it's minus 4 over x and plus c. For question like number 8, you use index law and actually add the powers. So 1 plus half is 3 over 2 because it's at the bottom. So therefore, when you bring it up as linear function, it becomes x to the power of negative 3 over 2. And then you integrate this. Negative 3 over 2 plus 1, you'll get negative half. And you divide it by half, you actually bring 2, negative 2 as the coefficient in front. And x power negative half becomes x, set x, written at the bottom. And of course, you add c. For questions like that, you can't integrate it directly. You have to actually expand the question first. So you expand this function. 1 times t squared, 3t plus t squared, 3t cubed. And then you individually integrate it using the basic law of integration. So therefore, it will become t3 over 3 plus t4 over 4 plus c. For number 10, the function is a squared function. Therefore, you have to actually expand the quadratic function first. So when you expand this quadratic, it becomes a quadratic function. So expand this using the normal expansion law. And then you will result in this. And then individually integrate each term. And of course, don't forget to add the c. For number 11, you actually have to combine the index first. So it is y squared and y to the power of 1 over 3. So 2 plus 1 over 3 is 2, 1 over 3, which equals to 7 over 3. And then you integrate y to the power of 7 over 3 by using the basic law of integration. 7 over 3 plus 1 is 7 over 3 plus 3 over 3, which will result in 10 over 3. Divided by 10 over 3, it gets flipped 3 over 10, plus with c. For number 12, integrate d theta. This is as if it is integration of 1 d theta. So therefore, it is, when you integrate 1, you will actually get theta because the unknown here is with respect to theta. So it's the same if you integrate dx, you will get x. So when you integrate d theta, is as if you integrate 1 d theta, which will result in theta plus c, of course, because this is an indefinite integral. So integrating sine and cos, just a recap, when you integrate sine, you will get negative cos. Like number 13, 7 is a constant, just leave the 7 there.
Integrating sign gives you negative cos x. So the resultant here will be negative 7 cos x plus c. For number 14, 5 is a constant again. Just leave the 5 alone. Integrating cosine theta gives you sine theta plus c. So I'm very sure by now you have actually observed the changes from dx, dy, d theta. So all this means the y here means dy means integrate with respect to y, theta means integrate with respect to theta, x means integrate with respect to x, and so on. So please pay attention what is the function integrated against. Same goes with number 15, 9 sine 3x. When you integrate sine 3x, you get negative cos 3x. Negative cos 3x, there was a 9 here, it's negative 3 here, so something has happened in between. When you integrate cos 3x, when you integrate sine 3x, it will become cos 3x over 3. Because this is the reverse of differentiation. So cos 3x over 3, 9 over 3 gives you negative 3 because integrating sine is negative cos. Same goes here. When you have cos 4 theta, when you integrate cos 4 theta, you will get positive sine 4 theta divided by 4. So 12 divided by 4 is actually 3 plus c, of course. Same goes here. When you integrate cos 5x, 7 is a constant, just leave the constant alone. Cos 5x becomes sine 5x, of course, divided by 5. The coefficient of x is always divided by the coefficient of x. And of course, don't forget to add c. Same goes here. 4 sine x over 3 becomes, integrate sine x over 3 is negative cos x over 3. And it is divided by 1 over 3 because that is the value when you get, that is the coefficient of x here. So 4 divided by 1 over 3 actually gives you 12 plus c.
Now you should apply all the rules that you learned in the previous slide and try to solve number 1 to 15 and compare your answers with the next slide. Number 13, 14, 15 and 8 require some simplification and expansion before you actually integrate the individual term. So make sure you apply the rules and try to integrate these functions. These are the answers applying the rule of integration from the questions from the previous slide. So please make sure your answers actually match these answers. Remember to try.
Okay, now we're going to learn about definite integral. Definite integral simply means integration of a function between x equals to a and x equals to b with respect to x or any other unknown. The most important application of definite integral is actually the area under the curve between xa and xb. This is read as the integral of the function from a to b. Obviously, a will be the lower limit and b will be the higher limit. So make sure a is always lower value than your b. How to calculate the integral is simply, once when you integrate the function, fx is actually the integrated function, the capital F. You substitute the upper limit into the function that has already been integrated and minus the function being substituted by the lower limit. And this will result in the area or value of the definite integral. Now we're going to look into how do we actually apply this definite integral calculation. Calculate integration of 0 to 1 of the function x plus 3 with respect to x. So therefore, first step, we integrate the function using the basic law of integration. So it becomes x 1 plus 1 over 2 plus 3 power of x power 1. Okay, this is the application of the law, and the resultant of the integral is here. x squared over 2 plus 3x. Now the next step will be, remember the previous slides showed, substitute the upper limit minus substitute the lower limit as x. So here one is substituted, one is the upper limit, so one is substituted into the integrated function. So you'll get this, and might take away, substitute 0 into the function. So obviously this resultant is 0. So your answer will reduce to 3.5 unit square. If it's area, we call it unit square. If the question just require you to calculate, then you just leave it as 3.5, value of 3.5. Now we're going to look into how do we apply this definite integral to actually calculate area under a curve. This area under a curve involves both the y and the x-axis. For example, if you have a curve which is bounded by the x-axis, so how do you actually find the area between the value of a and b, which is under this curve fx? The area under this curve equals to integration of lower limit is a, upper limit is b, the function of the curve, which is fx, with respect to x. And if you have the area which is below the x-axis, the calculation remains the same. It's just that it is actually, you can actually add a negative because the limits are still between a and b. You can add a negative, or you can actually do the same calculation but add a modulus for your a, because area under the x-axis is always calculate, the value will be always negative. So in this case, you must understand that area is a scalar quantity and the value can never be negative. That's why when you add a negative and you get a negative resultant, it will actually become positive. Next, area between the curve and the y-axis. So when you have the area which bounded by the curve and the y-axis, the calculation slightly changes. It's written as area of the curve bounded by the y-axis equals to integration of always lower to upper limit for the function, but the comparison between the first one and the second one is, the first one is bounded by x-axis, therefore the function is in terms of x. The second one is bounded by the y-axis and the limits also lie on the y-axis, so therefore it is in terms of y and bounded by the y-axis. So therefore the limit value of a and b is also values on the y-axis. For example, calculate the area under fx which equals to x between x5 and 7. So it's clear the function is x, the lower limit is 5, the upper limit is 7. So therefore area, integrate between 5 and 7. The function is x dx. The calculation will require you to integrate x first. So you will get x squared over 2. The limits are written as shown, 5 and 7. So when you substitute 7, 49 over 2, substitute 5, 25 over 2, and the resultant will be 12 unit square. So the area for unit, unless given, if it's not given, you can write it as unit square. Sometimes if it's given, it can be centimeter square, meter square, and so on. For this example, you have to calculate the area under a curve fx between x -1 and x 0. So it's quite clear the area is bounded by the x-axis. Lower limit will be -1 and upper limit is 0, and the function is as given. So you integrate the function given between -1 and 0. So first step, you integrate the function. x4 becomes x5 over 5, x squared is x3 over 3 between -1 and 0. So you substitute 0, the upper limit, into the integrated function, take away, substitute -1 into the function, which is the lower limit, and your end result will be 8 over 15. Unit square, of course. Let's investigate how do we count the area under the curve if it has a combination of area above and below the x-axis. Let's analyze this graph. X squared minus 6x plus 8. The graph is drawn as below. Okay. So you're required to find area under the curve which is bounded by the x-axis. So therefore, you actually have two parts of the area, which is between x0 and x2, which is above the x-axis, and between 2 and 4, which falls below the x-axis. So you have to calculate this area in two different calculations. So first you'll find the area which is shaded between x0 and x2, 0 and 2. So you integrate the function x3 over 3 minus 6x squared over 2, which is minus 3x squared, and 8 becomes 8x. So it's between 0 and 2. You substitute 2, take away, substitute 0, so you get 6 over 3. So this first part of the area between x0 and 2 has a value of 6 over 3 as the area. Now let's see what happens when we use the same method to find the shaded area between x2 and 4. When we find the shaded area between x2 and 4, the resultant is negative 1 over 3. Obviously, it's negative because the area is below the x-axis. So therefore, we have to write the area as a positive value for area. So it will be 1 over 3. So this is shown on the previous graph. When you integrate between 2 to 4, the value is negative because the negative sign indicates that the region is below the x-axis in this situation. So the actual value is found by taking the absolute value, which is the modulus. So therefore, in your calculation, you can either add a negative in front of the area below the x-axis, or you can actually put a modulus when the calculation actually gives you a negative value. So the absolute value here shows you that you should convert the negative to a positive value. For the next example, we're going to find the area bounded by the curve y equals to x cubed minus 1, the x-axis, and the lines x0 and 1. So it's quite clear the area is this region. Firstly, you need to roughly sketch the graph in order to know where the region lies. Next, you perform the area calculation as usual. The reason of putting a modulus is because the previous graph showed you the area is actually below the x-axis. Therefore, the modulus is necessary to actually change the negative value to positive in the end. For the calculation purpose, the limits were already clearly stated. 0, lower limit, upper limit 1. Function is x cubed minus 1. So therefore, the function integrated is x4 over 4 minus x between 0 and 1. And when you next step will be you substitute 1 minus substitute 4. The end result, you actually add a modulus. It will become 3 over 4. Calculate the area shown in the diagram below. This example shows area which is bounded by the y-axis and the function, and the y values as the limits, lower limit and the upper limit of the function. So therefore, you have to actually integrate fy with respect to y. So since you have y in terms of x, so you need to get x in terms of y. Means your function needs to be in terms of y. So as usual, we just make the x as the subject of the equation. Next, we integrate the function in terms of y with respect to dy, with the lower limit being 2 and 5 as given. So this is how you integrate y minus 1 power half plus 1 divided by 3 over 2, it becomes 2 over 3. And you substitute 5 minus substitute 2. And the end result will be 14 over 3 units squared. Okay, this graph shows the functions of fx and gx. Function of fx is given as stated, and gx is of the form of m cos nx. So therefore, we need to actually write down the values of m and n, find correct to one decimal place the coordinates of the point of intersections of the two graphs in the interval 0 to pi, basically these 2 points. calculate the shaded area. Shaded area is area between two curves, which is between fx and gx. So we will see in the next slide how to actually solve it. So writing down the values of m and n, we have to actually study the function gx. Gx is obviously a cosine function because of the shape of it. And the maximum minimum value has become 3 and -3 instead of 1 and -1. Therefore, the value of m is actually 3, which is the amplitude. And the value of n is actually the number of cycles for cosine. So up to pi, it has one complete cycle. Therefore, up to 360, pi equals to 180. Therefore, up to 360, it will have two complete cycles. So therefore, the value of n is actually 2 and the value of m is actually 3. Once you obtain your m and n, you actually substitute into gx. And to get the intersection points between gx and fx for part B, you actually equate gx with fx, rearrange it and solve your x. Make sure your calculator is in radian mode to get your value of 0.6 and 2.6. Then you are also required to find the y values by using either fx or gx. So this is the answer for part B. Answer for part C actually requires you to find area between the two curves. Is always the upper function minus the lower function, where in this diagram, fx is the upper function and gx is the lower function. You integrate, minus this two, and you simplify it. It becomes -7 cos 2x plus 3. So you're required to integrate -7 cos 2x plus 3 between 0.6 and 2.6 as the upper limit with respect to x. So when you integrate, your resultant will be 3x minus 7 over 2 sine 2x. Once you get your resultant of your integrated function, you actually substitute 2.6 minus or take away, substitute 0.6 into the function, and your end result will be 12.4 unit square as the area between the two curves. A curve has equation y equals to 2x minus 9 to the power of half. Show that the equation of the tangent to this curve at the point where x equals to 9 is y equals to 1 over 3x. So this is the question for part A. For this example, part A is actually application of differentiation and part B is application of integration, where you have to actually find A and then further part C is actually requires you to find the area. So in order to solve this question, first we need to prove the tangent equation. To prove the tangent equation, the first step will be the tangent touches the curve when x is equals to 9. So therefore, by differentiating the function of the curve, meaning obtaining the dy dx of this function y, and substituting x as 9, you will actually obtain the gradient of this tangent, which is 1 over 3. And when x is 9, you can find the value of y by substituting 9 into this function to get the coordinate y. So once you have the coordinate x and y and have the gradient is 1 over 3, you will actually manage to prove that the y equals to 1 over 3x. Okay, this is shown here. So when you differentiate the function, you actually get the gradient. And then you substitute into x as 9 into the function, and your y is actually 3. So you use coordinate 9, 3, and gradient 1 over 3 to get your curve equation, your tangent equation, and you will actually get y equals to 1 over 3x. And for part B, it requires you to find the intersection point. So to find the intersection point, you just have to substitute your x value. For part C, it requires you to find area, shaded area as is shown in diagram 2. So the easiest way to solve this question is to actually find the area of this large triangle, which is half times 9 and times height, which is 3. The height is obtained by substituting x as 9 into here and you'll get 3. So half times 9 times times 3 is actually 27 over 2. And you need to take away this area, the white colored area here. So this area is actually obtained by integrating the function 2x minus 9 power half with respect to x. So you integrate the function and you actually put in the lower limit, because point A is 9 over 2. The x coordinate of point A is 9 over 2 and the maximum value here is 9. So lower limit is 9 over 2 and upper limit is 9. So you substitute 9 and minus substitute 9 over 2, you will get a 0. So you will get, so the overall total area will be the triangle just now, which is 27 over 2. Take away 9, which is the area of under this curve, this white colored area here. So your resultant will be 4.5 units square.